Hi, this is Nimla Rednam. In this video, we are going to solve the sums on compound interest from the 7th chapter comparing quantities. In the previous video, we looked at the concept of compound interest and the formula and also its derivation. And in this video, we will solve all the solved examples, try these questions and the exercise sums. So let's look at the first question, which is the 8th example. Find CI, which is the compound interest, on 12,600 rupees for 2 years at 10% per annum compounded annually. So if I have to write the given information, what do we have? They're saying that the initial amount is 12,600, right? And they're saying the rate of interest is 10% compounded annually. And they're saying that we are supposed to calculate the amount, the interest after 2 years. As I told you, in order to find out the interest, we are going to first find the amount, and from that, if I subtract the principal amount, you're going to get the interest. And we already know the formula for the amount, right? Amount is equal to P times 1 plus R by 100 whole power n. And I know all these three values. So let's just quickly substitute those values. Okay. 1 plus 10 by 100 whole square, and this is 1 plus 1 by 10, which is nothing but 11 by 10, and because it is whole square, I am going to multiply it 2 times. Okay, and I can cancel the zeros, and 126 into 11 is going to give me 13, right? Again 11, 66, 88 plus 6 is 94, 33 plus 9 is 42. Okay, so I have 15,246. This is my amount after 2 years. Now, because they're asking compound interest, I'm simply going to subtract from this. I'll subtract the original principal amount. I'm going to get A minus B, which is nothing but 2,646, right? So this is how we are going to be solving all these sums. So that is a solved example. Now let's look at this, try this question. Find CI, which is the compound interest, on a sum of 8,000 for 2 years at 5% per annum compounded annually. Let's write down the information given to us. What is the principal amount here in this try this question? They're talking about a principal amount of 8,000 rupees, and they're talking about a rate of interest of 5%, and they're talking about a time period of 2 years, right? So I have n is equal to 2 years. So I'm going to use the same formula again. I will be getting the amount after 2 years as 8,000, right, into 1 plus 5 by 100 whole square. Okay, so this is nothing but 1 by 20. So I will get plus 1, 1 by 20 plus 1 is 21 by 20. I have to write it twice, right? So if I simplify this, I am going to have 21 square into 20. 21 square is 441, okay, and 441 into 2 is going to give me 882, and I have a 0 here. So that means that the amount is 8,820. They're asking us CI. So CI is nothing but amount minus principal amount, which is this minus 8,000, which is clearly 820. So that is my answer. Okay. So that is the try this question. Next, let's look at the 9th example. The population of a city was 20,000 in a year 1997. It increased at the rate of 5% per annum. Find the population at the end of the year 2000. Okay. So it's again the same formula is going to be applied here. So if you look at the information given to us, it's again going to be principal amount, or the original population is given as 20,000, right, in 1997, right? And now what is the rate of increase in the population? It's given as 5%. So this is going to be 5% annually. Per annum means annually. And what is the time period? From 97 to 2000, right? From 1997 to, that means it's 3 years time period. Okay. So if I apply the formula, the population in 2000 is going to be 20,000 into 1 plus r by 100 whole power n. Okay. So this is nothing but, again, this is 21 by 20, and because it is whole cube, I have to multiply it 3 times. So once the information is written in terms of P, R, N and so on, it's just applying the formula and doing the calculations carefully, right? So I have 10 here. Let's leave the 4 in the denominator for now. Okay. What I have in the numerator is 21 into 21 is 441. I already know that. One more 21. So this is going to be 9261, and I have a 0, right? So now divide this by 4. 4 2s 8, 4 3s 12, 4 1s 4, 4 5s 20, and I have a 0 here. 4 2s 8, and I have a 2 here. So I am going to put a point. I'll get 20, and 4 5s 20. With that, I can stop my calculation. So that's our answer, which is 23152.5. Okay, and we are going to approximate it because we're talking about population here, right? So the answer is 23,153. So you can see that with the formula or compounding it each year separately is going to give you the same answer. Next, let's look at this 10th example. There's no try this question here. A TV was bought at a price of 21,000. After 1 year, the value depreciated. We talked about this depreciation. The rate is 5%. Find the value of the TV after 1 year. So as I said, when we're talking about depreciation, what we will be doing is, instead of plus in the formula, we're simply going to get minus. We're simply going to put it as a minus sign. So initial amount as given to us is 21,000. That's the initial price of the TV, and the depreciation rate is set at 5%. 5% is the depreciation rate. After 1 year they want. So we're talking about n equal to 1 year. So the amount or the price after 1 year is going to be P into 1 minus R by 100. That's the only thing that we're going to do. Instead of plus, you're going to write minus, right? So this will give you, this is 20. So into 19 by 20. You have to simplify this and you're going to get the answer. So if you look at the multiplication 21 into 19, it's going to be 399, and then I have to divide it by 2, which will give me 1995, and I have a 0, right? So 19,950. This is going to be the depreciated value of the television after 1 year. Next, let's look at the try this question. The first try this question is, a machinery worth 10,500 rupees depreciated by 5%. Find its value after 1 year, right? So the principal amount is 10,500. The principal amount is 10,500, and we are talking about depreciation of 5%, and I want the depreciated value after 1 year. So n is equal to 1. So it's exactly the same as this example, the 10th solved example. So in this case, if I apply the formula, it is going to be 10,500 into 1 minus 5 by 100, okay, and which is nothing but 19 by 10. It's a minus again because it is depreciation we are talking about, right? And then I have 1050 into 19 by 2. So if I calculate this, so I have to simplify this now. This is equal to, so here if I cancel this 2, I have 5, 2, 5, right? So I have to find out 525 times 19. 19 5 is 95, okay? And 2 is 38, 38 plus 9 is 47. Again 95 plus 4 is 99. So 9,975. This is my answer. So this is about the try these question, where they're asking us to find the depreciated value of a machinery after 1 year. Next question, find the population of a city after 2 years, which is at present 12 lakh if the rate of increase is 4%. Here it's going to increase by 4%, okay, and the original population is 12 lakh, okay, the rate of interest is 4%, and the number of years that we are considering is 2 years. They're asking us what will be the value after, what will be the population after 2 years. So n is equal to 2. So now I have my formula 12 lakh, which is the principal amount, into 1 plus 4 by 100 whole to the power of 2, right? Which is 12 lakh into, I have, you can either simplify this, right, for 25, or you leave because you have zeros and it is very comfortable when you have zeros in the denominator. You can simply cancel zeros in the numerator, put so many decimal places. So you leave it like this, right? And now we are going to simplify this. So I have 104 into 104, 4 4 16, and then I have 104 here. This is going to give me 10816, right, into 12. 12 6 is 72, 12 ones 12 plus 7 is 19, and 12 eights is 96 plus 1 97, right? And then I have 12 ones 12, okay. Now here I have lakhs, which is 5 zeros, and I have 4 zeros in the denominator. So out of the 5 zeros in the numerator, 4 zeros are going to get cancelled. I'll be left with 1 zero. So the population after 2 years is 12,97,920. So that is your try these question about population. Okay, so now let's start the exercise. The population of a place increased to 54,000 in 2003 at a rate of 5% per annum. Find the population in 2001. Now here there is a slight difference in the wording and the information given to us actually. They are saying that they are going to give us the population in 2003, okay, and which has increased since 2001 at the rate of 5% per annum. So in 2001, whatever was the population, that has been increasing at the rate of 5% for a period of 2 years, because we have the population in 2003, and eventually in 2003 what is the population? It is 54,000. So I'm going to equate 54,000. So that's the difference here. You have to be very careful here, and A is nothing but, you're going to apply this formula, 1 plus r by 100 whole power n, right? Now From this, I can calculate P. This is 21 by 20. When I take it to the other side, it becomes 20 by 21. Right? It becomes 20 by 21. Now, if I simplify this, okay, I know that in the 3 table we have this 54. So 3 sevens, 318, again 3 sevens and 3 6, right? So now I have 6 fours 24, okay, followed by 5 zeros by 49. Now here, one way of doing this calculation is, now 49 table, you can see that whenever you have a number just very close to the tens, like 49 is just one less than 50, right? So 50 table is very easy. So from this 50 table, we can write the table of 49 very easily. So I'm going to tell you what I mean by that. So let me quickly write the table because it's a big number and I'm going to need the table. So 49 ones is clearly 49. Now what is 49 twos? You already know 50 twos is 100, right? So from this, if I subtract 2, I'm going to get 49 twos. And why is that? Because 49 is nothing but 50 minus 1. So into 2 is nothing but 52 is 100, which is very simple, minus 2. So here if I have 3, I'm simply going to have 150 minus 3. If I have 4, I'm going to have 200 minus 4 and so on. So quickly let's write down the table in that fashion. Right? So this is my 49 table. Okay. Now let's look at the division. I'll just take 240. I'll put the decimals and then cancel the decimals. Okay. So if I look at 240, you can see that it's 49 fourths is 196. Right? And you have 44 here. Put a decimal. 440 is 8s. 8s I have 392 and here I have 48, put a 0. 480 is again 9s, 441, 9, 3, take a 0, and 390 is 7s, 343, okay, 7, 4, 470 is 9s, 441. So I have a 9 and a 2. Now 290 is 5. 245, right? I have a 45 here. Now here, as you can see, I have 5 zeros, okay, and I have taken at least 5 of them, right? So this should be sufficient for an approximate answer. If I take one more number here, again I am going to get 9s, 441. This is going to repeat. Gone. So the answer is going to be, right, the principal or the original population is going to be, I have 5 zeros, right? So 4899795.9, right? This is what it's going to look like. 0.59, sorry, it is 1 2 3 4 5. Yeah, it's correct. I've taken 240, so I have only 4 more zeros left, not 5. So I have 1 2 3 4 4 8 9 7 9.59, right? So now if I approximate it, I can write it as 48980. So this is my approximate population in 2001, right? So the next question is, what would be its population in 2005? So that is 2 years from 2003. So here my formula is going to be P into, which is 54,000 into 1 plus in 2005. Okay, 1 plus 5 by 100 whole square, right? So this is going to give you 54,000 into 21 by 20, right? So now here I can cancel these zeros, 270 to 135, right? And I know that 21 square is 441. So I have to do 441 into 135. So I have, right, 13 and I have 441. So if I add them up, I'm going to get this, which is 59,535. So this is going to be the population in 2005. That is your first question. Next question. In a laboratory, the count of bacteria in a certain experiment was increasing at the rate of 2.5% per hour. Find the bacteria at the end of 2 hours if the count was initially 5,06,000. So what is the information given to us? The population, the bacteria count, okay, initially is 5,06,000. Okay, and the rate is 2.5%, right? And what is the rate is per hour, and the number of hours we are considering is 2 hours, right? So now we simply have to write, put all these in the formula and you will get the answer. So now here we are saying P into 1 plus R by 100 whole power n, which is nothing but 5,06,000 into 102.5 by 100 into 102.5 by 100, right? So here you can write this as, you can cancel the zeros, 3 zeros, okay, and then you can multiply these numbers. Let us do it. There's no division, so it's only the multiplication which is big, but that's okay. 25, 12, 5, right? And then I have double of this is 201, 2050, right? And then there's a 0, so I'll add one extra, and then I have 1025. So if I add these, I'm going to get 1050625, and then I have 506 here, right? 6 5s 30, 12, 15, 36, 37, 6 5s 30, 6 1 6. Again 2 zeros because I have a 0 here, 2 crosses, 25, 12, 31, right? 31, and then I have 25, 5 5 is 25, and then 5. So if I add these two, I'm going to get 6135, right? And then I have 3 decimals, 2 from here and 1 from here. Okay, so I'm going to put a decimal here, and it's going to be 531,616.25, approximately 531,616. So that's your answer for the bacteria count after 2 hours. Next question. A scooter was bought at 42,000. Its value depreciated at the rate of 8%. What is the value after 1 year? So here, what is my original principal amount? 42,000 rupees. What is the rate of depreciation? 8%, right? And I'm interested after 1 year, what is the price? Okay. So P into 1 minus R by 100 whole power n. That's it. Only thing is it's a minus because you're talking about depreciation, right? So this will give me 92 by 100. So this is simple multiplication. I have to multiply 42 with 92. Okay. 8, 18, 37, 3864. Okay. So 640. 38640. So this is your answer. That is the depreciated value of the scooter after 1 year when the depreciation rate is 8%. So with this we complete this topic comparing quantities, right? So in the next video we'll be starting the next chapter, chapter 8.